Alright, so Charles's law gives us the relationship between volume and temperature if pressure and amount are held constant. Think of it this way. As the temperature of a gas increases, the gas molecules will begin to move around more quickly and hit the walls of their container with more force. Thus, the volume will increase. Here's the mathematical form of Charles's law. V divided by T equals K. This means that the volume temperature fraction will always be the same value if the pressure and amount remain constant. So Charles's law represents a direct mathematical relationship. This means that there are two connected values, and when one goes up, the other one also goes up. So if the volume of a container is increased, then the temperature increases. If the volume of a container is decreased, then the temperature decreases. So let's allow V1 and T1 be a volume temperature pair of data at the start of an experiment. If the volume is changed to a new value, called V2, then the temperature must change to T2. The new volume temperature data pair will preserve the value of K. We don't really care about what the actual value of K is, only that the two different volume temperature data pairs equal the same value, and that value is called K. So getting rid of K, we can conclude that V1 over T1 equals V2 divided by T2. This form is very helpful in solving Charles's law problems. Keep in mind that you must use only the Kelvin temperature scale when working with temperature in all the gas law formulas, including this one. I'll say that again since it is so important. Every temperature used in a calculation must be in kelvins, not degrees Celsius. Here's an example. A sample of gas at 15 degrees Celsius and 1 atmosphere has a volume of 2.5 liters. What volume will this gas occupy at 30 degrees Celsius and 1 atmosphere? In this problem, the pressure remains the same while the volume and the temperature change, so it must be a Charles' law question. Before I solve this, pause this video and try it on your own using our Charles' law equation. V1 over T1 equals V2 over T2. Okay, I'm assuming that you tried it. So I'm going to start off by putting our given values into this equation. V1 is 2.50 liters divided by T1, and this is where you want to be careful. It's tempting to just use the Celsius temperature, but you must first convert to Kelvin temperature to get the correct relationships. So to convert from Celsius to Kelvin, we add 273. 15 plus 273 equals 288 Kelvin. So I'll input that into our T1 value, 288 Kelvin. We're looking for the final volume, so V2 divided by T2, which we once again need in Kelvin, so 30 plus 273 equals 303 Kelvin. So 303 Kelvin. So to continue solving this, we need to multiply both sides by 303 Kelvin to isolate our final volume. So times 303 Kelvin times 303 Kelvin. And this will allow us to completely cancel out the value on this side and cancel out the unit of K on this side. So what we have left is 303 times 2.50 divided by 288, and we're retaining our unit of liters. And so that'll give us a final volume of 2.63 liters. So this should make sense to you. The temperature is increasing slightly in the problem, so the volume should increase slightly as well.